started these problems on Wednesday. We were just doing basic, like geometry type problems where we could draw a picture and solve it from the picture. And then Thursday we got into the mixtures, and we found that when we have so much information, a chart is a really good way to organize that information. What was the formula that we were using when we solved these problems?
Amount, or is it amount? Yeah, it's amount times concentration equals total.
Yeah, you could call that total, you can call that amount pure. And remember, along the sides, we labeled our rows the different things that we were mixing together. So we had the two we were mixing and then our total. Okay, we're going to continue with these mixture problems today, but it's going to take a slightly different spin on them. And we're actually going to be calculating interest problems. Now, we can do this using the same strategies as before. So how do you calculate interest? Anybody?
I know I learned number 2. I don't remember how.
It's been about
2 years.
Principal times rate times time equals interest. Okay, you remember maybe I equals PRT. So it's still like a mixture problem, but across the top, if I'm talking about interest, we will be putting the interest formula instead of those concentrations. It's hard. Yes. So, except this time we're going to be doing some interest problems, so I was just giving you that formula that we're going to be setting up. One thing I want to mention, when you use the interest formula, your rate, if I say it's going to be 6.5%, if you have a percent, how do you put it into your problem? 0.065. You have to change it to decimal form. And in this formula, time is measured in years. Okay, so if I said you were putting it in for 6 months, you would have to say your time is a half. All right. So let's look at a couple. So Sarah has $70,000 to invest and requires an overall rate of return of 9%. She can invest in a safe government-insured certificate of deposit, but it only pays 8%. To obtain 9%, she agrees to invest some of her money in non-insured corporate bonds paying 12%. How much should be placed in each investment to achieve her goal? There is a lot of information in that problem. If you just read it, you probably get to the end feeling a little overwhelmed, thinking, I have no idea where to begin. Well, let's take a step back. How do we organize when we have a lot of information? Make a table. All right, so let's start with the table. What kind of thing are we calculating in this? Is this a concentration problem? This is interest. So I'm going to put my interest formula across the top. Principal times rate times time equals interest. And those are going to be the columns in my table. Okay, now we need to figure out the rows in our table. What are the different things going on here?
We're using the 8% one for the government insurance.
Mhm.
12% one for the corporate bonds. And then 9% is what she wants to.
Right. So you can label these 8%, 12%, 9%. It's the same as when we talked about the mixtures. You have to have your lowest and your highest. Your total has to fall in between those two. You could call them a CD, a bond, and a total. I don't care what you call them as long as you know what those things stand for. Okay, so we're going to have to take our lowest percent and our highest percent to get our grand total. $70,000 to invest. Is that the amount she put at 8%, the amount she put at 12%, or her grand total amount?
Grand total.
That is our grand total. That is what she started with. You went to your investment advisor and said, okay, I've got $70,000. What do I do with it? That's her total. She is going to invest it in two different ways. Did I say how much she put at 8%? No. So we could call that X. Now I also don't know the amount that she put at 12%. So could I just say both of those things are X? So why can't I say they're both X?
Because of different.
They're different amounts. Did I ever say you're going to split it in half and put some in each amount? No, so we can't do that. Okay, so this is really like a Y. Except long term, that's not a great solution because we can't solve problems with both an X and a Y, can we? But maybe this can help us figure it out. When we were looking at our problems last week, we always said if you can add the first two to equal your total. So would you guys agree that X plus Y would equal 70,000? Could you solve for Y here? Yeah. If you want to get rid of the X, you just subtract it over. So Y is 70,000 minus X. So that is actually what I'm going to use here. Another way of thinking about it. You have $70,000. If you give me $20,000, how much do you have left? 50. You get it by subtracting your total minus the amount you've already used. Right. So that column is a little bit different than what we were doing last week. Do you guys have questions for me right here? Let's see if we can fill in the rest of our table. So then our rates. The rate is kind of given to me because I've already labeled my percent. 8%, so my rate would be 0.08. 12%, 0.12. 9%. My time. Does it tell me anywhere how long I'm investing these? No. On these investment problems, typically I'm going to be talking about annual. Really, as long as all of your times are the same, it'll work out. But my standard is if I don't specify, let's just do 1 year. A lot of times the problem will say annual interest, and annual means 1. But if I don't give you a time, just assume 1. So then how do I get my interest? Multiply. Principal times rate times time. So X times 0.08 times 1 must be 0.08X. Okay, when I multiply these, 1 times anything is itself, so we get 0.12 times the 70,000 minus X. Down here, you're going to have to do your 0.09 times 70,000. So if you want to go ahead and do that, what do you get? Once we get to this point, then it is exactly like what we were doing. So if you can get this total box, your equation writes itself. What do? Add the first two to equal your total. Look at that positive reinforcement. What a pal. Alright, so now we just solve. So if we distribute 0.12 times 70,000 2 times a negative x be negative 0.12x. Okay, add like terms. So I get a negative 0.04x. Subtract over my 8,400. And when you divide, what do you get? Thank you. Am I done? Okay, answer your question. So the original question said how much must be invested at each amount. So there should be $52,500. What does that represent? That was my X. So if I look back at my problem, X was the amount at 8%. How do I find the amount at 12%? Subtract. 70,000 minus X. 17,500 at 12%. Alright, questions on this one? I'm going to give you the next one. I want you to take 2 minutes and try to set it back. Let's see how much we got. So, if nothing else, what formula goes across the top of your table? See, you guys got that.
That'd be my points, right? That'd be points right there.
There's a point.
8.
Okay, what things are we mixing together?
I know the T's are all one.
Okay, our T's are all 1 because it says interest per year.
Oh, pretty good.
What are my row labels going to be? Our percents. Now,
30% first.
the 30%, this is the trick to this problem. Is the 30% how I'm actually going to invest it? No. Okay, so you guys have jobs, right? You go get a job, and you go to work for 8 hours, and they say they're going to pay you $10 an hour. Do you go home with $80? No. Why not? What happens to your money? The government takes taxes out of it. So even though they say you're going to get this much, once they take out taxes, your check that you bring home is small, right? That's what this 30% is. She won $200,000, but is that the amount she gets to keep? No. If you win the lottery, the government's going to take its share first before you ever get your money. So the government is taking 30% of her winnings. How do I figure that out? What am I going to do? Okay, so to find out the taxes, you have your amount she won. If you take it times 0.3 for 30%, how much did she pay in taxes?
60.
Okay, so the government is going to take $60,000. Out of what's left, she's going to break it up, and she's going to put some in this investment that's going to earn 1.5%, some in this investment earning 4%. So those are my 2 different investments. Did it tell you the rate on your total one? So I'm just going to call this So my total is not $200,000 because she didn't walk home with that much. How much did she actually get?
$60.
Yeah, you have to take the amount she started with, subtract off your taxes. So she is only actually earning $140,000. All right, tricks are done from there. Now it's a normal problem. So. Okay, so our principal, do you know how much was invested at 1.5%? No. All right. Did it tell us how much was invested at 4%? It didn't say it was twice the amount or anything. So what am I going to do? Right, your total minus X, the amount you've already used.
That's why she's investing,
All right, so your rate, 1.5%, what would that be as a rate? Because you always divide by 100, move it back to 4% would be 0.04. Do I know the interest rate on my total? No, so I'm going to have to leave that blank. I don't know it. Now, we did already decide interest per year, so that's 1 year. So if we multiply, okay, I've got a problem. I can't just multiply to get this last box because I don't have everything filled in. It's a number. I gave it to you. You earn $4,350 interest per year. That is your total interest, so you can just write this down. It is okay to have holes in your table, things that you can't fill in, as long as you can get this final column. So it didn't give me that interest rate, but what it did give me was the total interest. So we're okay. So now, do your formula. Add the first two. To equal your total. Okay, so 0.04 times 140,000. Okay. All right, 0.015 minus 0.04. Negative 0.025. Okay, subtract over your 5,600. Divide. What do you get? Okay. So then, answer the question. We were just asked how much did she invest at each rate. So Linda, and right, 140 minus that would give you 90,000 at 4. Okay. All right. Hey, you never know. Someday you may be making those financial decisions yourself. So, gotta be able to balance it Alright, where are you guys at with these? Do we need another problem like this?
No, I say we did it. On most of them.
Funding complex coming to mind.
You're just saying that so we move on.
No, like, I actually had this down.
Okay. Are we okay with these?
Yep.
Let's look at a new problem. Alright, so Peripheral Visions produces high definition DVDs of live concerts. The company places an ad in a trade newsletter. The cost of the ad is $100. Each DVD costs $20 to produce, and the company charges $24 per DVD.
This is a problem. So they're just starting to figure.
No, because you're honest people that want to pay for the stuff you're going to watch. You're not going to steal and watch it on YouTube.
You don't watch it on YouTube, you have to pay for it on there, you just steal it off the legal website.
I'm going to pretend that I'm teaching a bunch of honest people that are going to go pay for their things.
Oh, I'm not paying for
So,
that. Talking about that.
for
I'll tell
A,
you that right now, I'm not paying for that.
express the cost of the function of X, the number of DVDs sold. Okay, we're trying to write out a cost equation. I'm going to use function notation here. So cost as a function of X, that's like C of X. So our cost is our Y value, X is the number of DVDs. So these are going to be linear equations, because that's all we know how to work with yet. So a linear equation, Y equals mx plus b. When you are talking about that, m is your slope, that's your repeated cost. B is your y-intercept, your one-time cost. So when I look up at this problem, what are the costs that the company is going to incur?
The cost of the ad and.
Alright, they have to pay for their ad and their DVDs. So which of those is a repeated cost? The 20, because they pay $20 for every DVD they produce. 20x plus 100. They're only running that ad one time. There's your cost equation. So revenue is a function of X. So we're going to call that R of X. Revenue is the amount of money you bring in. They're receiving $24 for every DVD. So that's 24x. Do they have any other lump sum payments? Did anybody just cut them a check for no reason? No, so that's the only money they're bringing in. Tips? Well, you dishonest people are just stealing it anyway, so I wouldn't count on
I ain't
tips.
paying that, come on now.
Alright, for what value of X does revenue equal cost? So we want to know, this is what's called the break-even point. If you ever go out and start your own business, you're going to be very concerned with a break-even point. Because that's the point where the amount of money you bring in is the same as the amount going out, right? So what am I going to do here? Okay, so if I subtract over my 20x, x equals 25. So what does that mean?
That means you just sell 25 DVDs to make it for the cost of the ad.
Okay, so if I sell 25 DVDs, I go home with no money. If I sell less than 25, then I've lost money in this deal. But if I sell more than 25, then you actually start making money. Alright, questions there? Let's do, I'm going to give you guys one of these to try, and this will probably be our last problem for the day. Alright, so your cost. Okay, the cost that the baker incurs. We have three numbers in this problem. What does it cost her to make each cake? And she has to pay how much to get to the fair? Okay. Her revenue, how much does she bring in for each cake? So then your break even, you set those things equal. So we get 4x equals 40. So if she sells 10 cakes, she breaks even. Anything above that would be a profit.
I'm just kinda think like our money system goes up like 100 cents instead of like 50 or something, you know, so I don't have to convert it.
Okay, so game plan.
There's 20 problems.
The next problem would take me. You'd only have a couple minutes left if I start the next one. So, on the handout, you are ready to do problems 8 through 10. And then tomorrow we will finish everything else.
That's a lot, I don't know if I can do that many.
I know, it's getting pretty rough.